Okay, this is part 2 of perpetual motion for everyone. I think I forgot to say that once these batteries are charged, they can then be wired in series. So this is the higher voltage, and then these wired in parallel. So this would then be 12 volts, right? Or the lower voltage, depending on what voltages we're working with. What's important is that the voltage is always higher on one side and lower on the other side, and then we're moving the energy from one set of batteries to the other. Once these batteries deplete, once they're depleted of their energy, and if they're lithium batteries, that would be once they're at the point where you have to stop because you don't want to discharge them below a certain amount. Then the batteries are rotated, meaning this side would then be wired the way this side is, and this side would be wired the way this side is. So that takes time. That takes time to do all that. But I think it's faster than waiting for all these batteries to charge under normal conditions. If we're waiting to charge, batteries take many hours to charge usually, right? And in this kind of circuit, the time, instead of waiting for the batteries to charge, we just spend a little bit of time rewiring everything and then allow the energy to flow back the other way. So then we use these batteries to charge these batteries. Okay, everyone, perpetual motion for everyone. This is it. You can just keep on sending the energy back and forth, back and forth, back and forth. And don't forget, even though electrodynamics seems to claim that generators make energy just from the coils endlessly, my understanding is, from studying Thomas Bearden and Donald Lee Smith and hundreds of other inventors, it looks to me like my interpretation of what everyone's saying is that the coils in a generator are actually getting the energy from the environment. That looks like where the energy is actually coming from, which is the reason that we can have a circuit that actually allows us to go further than 100% efficiency, right? Because this overall circuit, right? This overall circuit is going to allow, I think we can call it a greater than 100% efficiency. What I mean is the motor and generator are the efficiency that they are, right? They have a rated efficiency, but by wiring the circuit differently, it allows us to not short circuit that energy that's in the batteries, right? Because the alternative to this would be, we have a battery here. Let me think about this. Yeah, and then we have a plus and a minus, and this is a 12 volt battery, and then we have that running a generator or a motor. We'll have that run a motor, right? So the motor is a plus and a minus, so we connect the plus to the plus and the minus, that's our switch, minus to the minus, and that's going to make this generator turn, right? It's going to make it turn. And then if we put a generator here, the power would be so low that if we sent that back to this battery, it's not really going to do anything, right? We can't, it's kind of like, it's very inefficient. We can't go anywhere with this, right? This is not something that we can keep running because the energy just got, we drain this battery without giving it to any other battery, right? To me, it makes more sense like this circuit up here, because this is not a perpetual motion circuit. See, anyone that says you have to do this and only this, I think tends to come from a place of saying that there's no energy in the environment. But to me, once we acknowledge that energy is in the environment, but I don't even know if you have to acknowledge that. But I mean, because people seem to understand this without even understanding anything about electrodynamics or particle physics. They seem to just know intuitively that a circuit could be more efficient. They may not know how to do it though. I intuitively understood somehow that there's more, because that's part of the language that we grow up in, is that there's more, there's always another way to do it. There's more ways to do things. Anything's possible. Anything you can imagine is possible. I mean, these are big things. And the question is, how do we keep asking questions, and how do we keep doing experiments, and how do we discover our thoughts in the process of sharing that discovery process with one another? That's a big one. Collaboration is really big, and this is part of my collaboration experience, my making this video. And that's the least I can do. I mean, I want to do everything I can to give back to the very community that made that created the opportunity for me to learn the things I've learned. Thank you so much. I thank all of you. So here we are. Don't forget, all these things, all these generators, batteries, and motors exist in an energy-rich environment. And it appears to me that the coils of every motor and generator are interacting with that energy in the environment. Very important. And is there a little energy or a lot of energy there? A lot. So just read, what did John Wheeler and Richard Feynman say? In the area of like a teacup, right? There's enough energy to power, I think we could power the world with that, with the energy in a teacup. That's not an exact, that's a paraphrasing, but my research and study indicate this, what I'm saying to you, okay? But that's often been referenced in different ways, you know, saying, I think the way you'll find closer to the exact quote is that we can not just power cities and and boil all the Earth's oceans. Many different examples, a lot of references to the power available in a small area. Well, our circuits all exist in that same space, that energy-rich space. So the question is, how can we wire the circuits differently? How can we understand what's taking place in a way that lets us have a more efficient circuit? Only we can do it for ourselves, right? We can only do it for ourselves. And sharing your thoughts on the theory is very important. Okay, everyone, until next time.